Guys, so today we're going to continue solving, but what we're going to do today is we're going to look at solving, not just solving for x, but actually solving for different variables and having answers that involve lots of variables. So if any of you guys were in physics right now, you've probably done something similar to what we're going to call literal equations. Literal equations really just mean there's going to be a whole bunch of letters involved. Now, don't be too alarmed. It's not too terrible. It's actually something you've done before. A lot of you guys have probably seen questions like this for SAT and ACT prep, but the most common place you guys have done this year is when finding an inverse. So for finding inverses, if you think about it, we're solving for y and our answer has x's in it. Now, this is kind of a basic example, but we're going to start with the inverse of this rational function to get you guys used to the process. So remember, as we've done multiple times this year, the way we find an inverse is we switch x and y. So now there's a couple different ways we can go about solving this. I am going to either cross multiply or multiply both sides by y plus 7, however you want to look at that. So I'll have x times y plus 7 is equal to 3y minus 2. All right, so now at this point I need to get y by itself. Now you'll notice a problem though. I've got a y over here, and I've got a y over here that's inside the parentheses and multiplied by x. So what I'm going to do is I'm going to go ahead and multiply that and distribute that on that left side. Make that xy plus 7x equals 3y minus 2. So in order to solve for y, what I'm going to do is I'm going to get every term that has a y on the same side of the equation. And I'm going to get every term that doesn't have a y and put it on the same side of the equation. So I'm going to subtract 3y from both sides. And I'm going to subtract 7x from both sides. So now everything with a y is on the left, everything that doesn't have a y is on the right. The reason I'm doing that is that allows me now to factor out that y from both of those terms. Now that that y is factored out, it's the same thing as if I have 3x equals 12, okay? I can just divide by what's with the variable. So I'm going to divide both sides by x minus 3, and I end up with my inverse, which is negative 7x minus 2 over x minus 3. One good way that you can also make sure this answer makes sense, let's look at our original equation. It has a vertical asymptote at x equals negative 7. Well, if I flip x and y, this should have a horizontal asymptote at y equals negative 7, which it does. All right, look at the next one. Or the horizontal asymptote, y equals 3 because it's the same degree. Vertical asymptote here, x equals 3. So that's one way we can check our answer. Now again, it's not a guarantee. Make sure you go through the process, but that is something we can do to kind of quickly check and just make sure our answer is reasonable. All right, so what we're going to do now is we're going to look at some literal equations. And this is going to use the same solving strategies we did last class, but our answer is just going to be in terms of a bunch of other variables. So on this first one, we're going to solve for x, okay? But you'll notice I've got y's and z's in my question, which means my answer will have y's and z's. Your answer can look several different ways and still be correct. Now, if it's a multiple choice question, you'll need to kind of manipulate a little bit to make it look like one of those answers in your multiple choice, similar to something you may see SAT or ACT. If it's free response, though, there are a couple different ways you can write it. The important thing, though, is that your x is completely by itself in your answer. All right, so what I'm going to do here is I'm going to go ahead and cross multiply, all right, since I have a fraction equal to a fraction. So I'll do z times y plus 1. And then I'll have 6xz. One thing I would recommend doing on these is I would put a little line through your z's, is because a lot of times the z's start to look like 2's, so just be careful about that. So find a way to differentiate your z's from your 2's. All right, now I'm going to go ahead and get x by itself. So in this case, if you want to go ahead and distribute, you can. I'm not going to, because if you'll notice, what's currently with the x, the only x in my problem, is 6 and z. So if I divide by 6 and z, since this is multiplied by this factor, it's okay to go ahead and cancel out those z's. So I can go ahead and do that. Now, if this was a z, okay, then that would be a different story, because again, that would be added. But that z is multiplied, it's a factor, it is okay to go ahead and cancel it out in that case. So I'm left with x equals y plus 1 over 6. All right, let's go ahead and try the next one, solving for c. So again, I'll go ahead and cross multiply. So I'll get a times c equals b times c minus 1. Now, a little bit of a different story here. I can't just divide by a because then my answer still has a c in it. That doesn't work. I have to get all of the c's together. So I'm going to use a similar strategy that I did on the inverse. I'm going to go ahead and distribute. And I'm going to get everything with a c on the same side of the equation. So I'm going to move that over. So I'll do AC minus BC equals negative B. Now both terms over here have a C, so I'll factor it out. And then divide by what's with it. So I'll divide by A minus B. So I get negative B over A minus B. Now keep in mind, again, there are different correct ways to format your answer depending on how you solve this. Let's say if instead you did B equals BC minus AC. Okay, then when you factored that out, you would divide by B minus A, and you would get this as an answer. That's not wrong. It's just a different way of rewriting it. Because again, essentially what you have here is this negative, and if you had that negative kind of moved into the bottom instead, okay, because again, like a negative 1 over 2 is the same thing as 1 over negative 2. Okay, if that negative was in the bottom, you would get that same fraction that you have over here. Okay, so if I rewrote that as B over negative A minus B, that's also a correct answer. Okay, so again, different ways that you can write this. Now, the big thing you need to be careful about here, what you cannot do, okay, is cancel out those B's. Those B's cannot be canceled, okay? That's a very different situation than what we had over here. Over there, it was a factor, okay, that when you can cancel out that factor. The factor here is B minus A, okay? Those B's do not cancel, okay? This is as far as you can simplify. Do not try to do anything more. All right, so now let's look at some that where common denominator is going to be kind of our best strategy. Okay, so in this case, we're going to solve for r. Well, what I'm going to do is I'm going to go ahead and get to that common denominator. So I currently already have a common denominator on these two terms. So I could do actually a couple different things. If you wanted to, you could go ahead and subtract it over there, combine those together and cross multiply. That's one option. But I'll go ahead and do common denominator just because we haven't done that yet. So I have r squared and just regular r. So that fraction on the left is going to need to get multiplied by r. So now I have SR over r squared plus t over r squared equals t plus 2 over r squared. Well, now the denominators are all the same. These have to be the same as long as the numerators are equivalent. So I am just going to solve my numerators. So I've got SR plus t equals t plus 2. I'm solving for r, so I'm going to get the r term by itself, so I'm going to subtract t. Well, t minus t is going to go away, and then I'll just divide by what's with it, and I end up with 2 over s. Now, on these questions, it is good to know, s could not be 0 because we can't divide by 0. R also cannot be 0 because in the original problem that couldn't happen. Now, for something like this, I'm not going to make you guys do those exclusions. I'm more concerned with you guys understanding how to work these out algebraically, but that is important to know, and that is something you may see come up in future classes. All right, let's try one more. So again, on this one, R1, 2, 3, and regular R are actually different variables. Again, if you're in physics, you've probably seen some similar things to this. So I want to solve for just regular, plain old R. Okay, and again, different ways we can do this. I'm going to go ahead and get a common denominator for all 4 terms. Well, since each one of those is a different variable, essentially it's x, y, z, and we'll say w. Okay, I need to multiply every fraction by the other denominators. So this one's going to have a lot of writing and a lot of r's. Okay, so my common denominator is going to be r times r1, r2, r3. So what that means, the left fraction is going to need r, r2, and r3. It means the middle fraction is going to need r, r1, r3. It means the third fraction is going to need r, r1, r2. And it means the right fraction is going to need r1, r2, and r3. So if I multiply top and bottom by both of those things, I would end up with R, R2, R3 over the common denominator, plus R, R1, R3 over the common denominator, plus R, R1, R2 over the common denominator. And that's going to equal R1, R2, R3 over the common denominator. Okay, saving myself some writing. But in this case, hey, we have the same common denominators, okay? So I'm just going to solve those tops. So I'm just going to write the numerators there to save myself some time of writing. And it's going to equal that. Okay. So now again, let's remember what we're solving for. The original problem wants us to solve for regular, plain old R. Every term on the left has an R, which is great. It's already set up the way we want it. That means I can factor it out. So R gets factored out. That leaves me the first term, I have R2, R3. In the second term, R1, R3. In the third term, R1, R2. And I didn't change anything over here. So now to get R by itself, just divide by what's with it. And those of you guys using Notability, you won't have to rewrite this like I am. You can just copy and paste, or duplicate, which I cannot do, but because I'm not using Notability. But you get the idea. I'm going to run out of space. So after all of that writing, I end up with R1, R2, R3 over R2, R3 plus R1, R3 plus R1, R2. So lots of R's, lots of writing, but the process here is the same thing that we did last class. Get a common denominator, solve the numerators. Okay? If you wanted to, you could have gotten a common denominator just on these ones and then cross-multiplied. Again, multiple ways to do this and multiple ways to write your correct answer. The important thing is that in the end, you have that variable it's asking for by itself, and that variable is not anywhere else in your answer. All right, guys, so that is it for today. Pretty short video. Really just important for you guys to get some practice on these types of problems today.